This video is going to show you how to convert between the gram unit and the mole unit in chemistry. Now, previously you should have already learned how to calculate the molar mass of a substance or a compound, and you should also have learned how to convert from moles to particles or particles to moles. These are going to be similar conversions, we're just using different units. We're going to use grams instead of particles. So let's get started. Here's a practice table. You have this in your note-taking guide. We're going to actually go through and fill these in together. Alright, so in the first row there, the compound that we're being asked to look at is HCl, or hydrochloric acid. The first thing we need to calculate is the molar mass of that compound. So let me get my pen going here. If you look on your periodic table, HCl, remember, has one hydrogen that has a mass of 1 gram and one chlorine atom, which has a mass, if you round it to the nearest whole number, of 35 grams. So the molar mass of hydrochloric acid is going to be 36 grams per mole. That's going to be our conversion factor. So we are given, over here on the right, 0.25 moles. To do a conversion with this, I write down what I'm given first, the 0.25 moles, and we're going to set up our conversion factor right here in the box. I know moles has to cancel out, so I'm going to put 1 mole on the bottom, and then I'm going to use this molar mass that we calculated over here on the left side to go in the numerator position. I'm going to put my 36 grams there. This is using the molar mass as the conversion factor from moles to grams. Now the math is simple. Moles here cancels with moles here, and we're just going to type it in the calculator the exact way that we read it from left to right on the screen. 0.25 moles times 36. And if you do that correctly, you should come out with 9 grams. That's the mass of 0.25 moles of hydrochloric acid. Let's try a second one. H2SO4. This is sulfuric acid, or hydrogen sulfate. If you count the atoms to get that molar mass first, we have 2 hydrogens. That's going to give us a total of 2 grams. I've got 1 sulfur. On the periodic table, sulfur has a mass of 32 grams. And we have 4 oxygens. Each oxygen is 16 grams. If I do the math correctly, 16 times 4 is 64 grams. I need to add all of those numbers together. That gives me a molar mass for H2SO4 of 98 grams per mole. And again, we're going to use that as our conversion factor. But look at this. This time we're given 53.15 grams of the compound. So when I set up the conversion factor, it's not going to be exactly the same as it was in that first row. This time I need grams to cancel out. So I'm going to put the gram unit on the bottom. I'm going to put the mole unit on top. The relationship here is that in 1 mole, there's 98 grams for H2SO4. Grams cancels with grams. When you enter this in your calculator, you're going to type in 53.15 times 1. Work all the way across that numerator, and then divide by 98. The grams cancel out, and you're left with 0.5423 moles. Let me just put equals here. 0.5423 moles. Okay? Next one. Sodium chloride is the compound. So we have 1 sodium and 1 chlorine. And if I use my periodic table, sodium has a mass of 23 grams and chlorine has a mass of 35 grams. Add those together, so the molar mass of sodium chloride is going to be 58 grams per mole. Remember, that's going to be the conversion factor. So in the problem, I'm given 3.55 moles of sodium chloride. That's just table salt. The conversion factor is going to go there. You always write down your given first. I need moles to cancel out, and guess what's going on the top? It's that molar mass that we just calculated. So moles cancels with moles, And when I do the math, if I have 3.55 moles of sodium chloride and each mole has a mass of 58 grams, I get 206 grams of sodium chloride is the answer for this one. Alright, great. One more. Let's see. Hopefully you're getting this pattern now. I've got an element here, copper, but that's not going to change anything about our math. If you look up copper on the periodic table, the mass of copper is rounded to 64 grams per mole. Okay, so in this example, I'm given 1.27 grams of copper, and I need to figure out how many moles of copper that is. So let's put that 64 grams down on the bottom, because I know grams here has to cancel with grams below. I'm going to put 1 mole on top. We're just using that molar mass again as our conversion. But this time I'm going to need to divide. So in your calculator, 1.27 times 1, and then divide by the 64 gram number, and you're going to get a lot of decimals in your answer, but we want to round off. We can put 0.02 moles. And that's the answer to convert grams of copper to moles of copper. Let's see if you've got the pattern. We're going to work some more problems out, but this time they're going to be word problems. Let's do some mole mass practice problems. These are also on your note sheet. We'll just go through them slow and together. The first one is, how many moles are represented by 16 grams of ethanol? And you're given the formula for ethanol there. Now, when you think about this, find your given. You're given 16 grams of ethanol, and it asks you how many moles. So the problem we're looking at here is to convert from grams to moles. Now, if I'm going to do that, I think the first thing I want to do is use the pattern that I've looked at already. I'm going to need to write down my given first, which is 16 grams. 16 grams needs to be converted to moles. So what I'm looking for goes on top, and the unit I have needs to go on bottom. Remember to cancel out, just like in those other problems. So I know that in 1 mole there are going to be a certain number of grams. What I need to do is kind of go over here in a separate area, and I need to work out the molar mass of this ethanol. So when I count my atoms, I have 2 carbons, I have 6 hydrogens actually. There are 5 in the middle, and then the 1 on the right end. Don't forget that one. And I have 1 oxygen. Each carbon is 12, so that's a total of 24 grams of mass from carbon. Each hydrogen is 1 gram from the periodic table, so that's a total of 6 grams. And each oxygen is 16 grams. There's only 1 of those. So add all that together, and I get 46 grams per mole is the molar mass for ethanol. Alright, so let's plug that in right there. Grams cancels with grams, and when I work that out, it's going to be 16 times 1 divided by 46, and I get 0.348 moles. Okay, so that's the answer for that one. Convert 16 grams of ethanol to moles and you get 0.348 by using that molar mass. Let's try another one. This time we are given molecules of glucose, and we need to figure out how many grams there are in the 6.63 times 10 to the 23rd molecules. So this conversion has some of those particles in it like we were looking at last time. What we're going to have to do here is convert particles to grams. Now for that to happen, we've got to use the mole. So I think this is going to be a 2-step conversion. Write down what you're given first. 6.63 times 10 to the 23rd molecules. Watch your abbreviation for molecules. Don't make it look like moles. Now I need molecules to cancel out. So this is a little bit of review. But do you remember that in 1 mole there are 6.02 times 10 to the 23rd. Remember, that's Avogadro's number. I'm going to put that in parentheses here to help you with the math in your calculator. That's going to allow molecules here to cancel with molecules here. That gets me to moles. But then I need to go to grams. So I'm going to set up another conversion factor. And I'm going to put 1 mole on the bottom here so that moles cancels with moles. And then grams is the unit I'm trying to find. The grams is going to come from the formula of this glucose. So up here separately I'm going to find the molar mass for that. I have 6 carbons, 12 hydrogens, and I have 6 oxygens. Now carbon is 12, so 6 times 12 is 72 grams. Hydrogen's mass is 1 gram, so that's a total of 12 grams. And then oxygen is 16 grams from the periodic table, and so if I multiply 6 times 16, I get a total of 96 grams. We need to add all of that together. That gives me 180 grams. That's the molar mass of that glucose. And I'm going to put that 180 grams right there. That's the proper conversion factor for this one. Now, we've got our numbers all filled in. We've got our units all canceled out. Let's type all this in your calculator. You're going to do 6.63 times 10 to the 23rd times 1, and then times 180. I'm just reading from left to right across the top of the conversions. And then I'm going to divide by 6.02 times 10 to the 23rd. Now remember, when you divide by Avogadro's number, you may need to put that in parentheses in your calculator so that you get this correct answer. The answer that I got in the units grams, let me put my equal sign here for you. I got all of this to work out to be 198 grams. If you did not get that answer, remember, check your calculator for the exponent at the end. If you have an exponent but you have 198 or 1.98, you probably have just typed it in the calculator incorrectly. So try it again and put that denominator, the Avogadro's number, in parentheses. See if that helps. Alright, let's work some more. In this third problem, we are finding moles of methanol, and we are given molecules of methanol. So the problem here is asking us to convert from molecules to moles. Remember that we need to write down our given first. Our given is going to be those molecules. So I'm going to start with 6.53 times 10 to the 23rd molecules. And I'm going to multiply it by that conversion factor. I need molecules to cancel, so I'm going to put it on the bottom. And I need moles on top. I remember from an earlier lesson that 1 mole is 6.02 times 10 to the 23rd molecules. Molecules cancels out. We're going to divide by Avogadro's number. And let's do that math real quick. 6.53 times 10 to the 23rd divided by 6.02 times 10 to the 23rd. That gives me an answer. I got 1.08 moles. Now you may be thinking, well, why was this problem in this PowerPoint? Because it's a review question. I didn't even use the grams for methanol. That's exactly why it's in this PowerPoint, because I wanted to have you look at it and recognize that when you're working with molecules or particles, atoms or formula units and moles, you don't need the grams or the molar mass of the substance. They will give you its formula, but you are not required to find the molar mass in order to do this conversion. The only time you need the molar mass is if your problem involves grams. Okay, let's take a look at the next one. How many moles of sodium chloride are in 16 grams of sodium chloride? Now this one's got grams in it, so guess what? We're going to have to find the molar mass of sodium chloride. This problem is asking us to go from 16 grams of NaCl to moles of NaCl. Well, if you look back on that chart that we filled in first in this video, remember that the formula mass for sodium chloride was 58 grams per mole. So we already have that. I'm going to go ahead and write down my 16 grams. And we know we have to convert it to moles. So I'm going to put the unit mole on top and grams on the bottom. 1 mole is 58 grams. I got the 58 from adding together the atomic mass of 1 sodium atom and 1 chlorine atom from the periodic table. So the grams here cancels with grams here. That seems easy enough. And we're going to say 16 times 1 divided by 58 in a calculator. You do get a really long string of decimals for your answer, but I want you to do a little bit of rounding here. We're given 3 digits in our given number, so I want you to use 3 in your answer. So 0.276 moles of sodium chloride is the answer for this one. I hope these are starting to get a little bit easier for you and that you're recognizing the patterns and how to figure out the conversion factors. But I have a few more just in case. Let's look at these last ones. In this problem, they give us 40.6 grams of potassium hydroxide. And since it's got grams, I know I'm going to need the formula mass. So I've got to get the formula for potassium hydroxide, and I'm going to go to molecules. Now, the conversion from grams gets me to moles. And then I have the old conversion with Avogadro's number to get from moles to molecules. So this actually is going to be a 2-step conversion. The first thing I need is to write down my given. I'm going to use 40.6 grams, and I think I need the formula for potassium hydroxide, so you can go look that up if you're ever in doubt. I'll go ahead and give it to you in this one. Potassium hydroxide is KOH. So I'm going to put 1 mole on top, and I need grams on the bottom. And then I'm going to go ahead and set up the second conversion. The mole's going to cancel out there, and I'm going to put molecules on top because that's the ultimate unit that I'm trying to figure out. I know that in 1 mole there is 6.02 times 10 to the 23rd molecules, and I've got to get the molar mass of KOH. So go look that mass up. Potassium has a molar mass of 39 grams. There's 1 of those. Oxygen is 16 grams, and hydrogen is 1 gram. So this gives me a total of 56 grams per mole. There we go. So I'm going to plug that into this spot here. Grams cancels with grams, moles cancels with moles. I'm going to be left with molecules. So let's do all that math and see what we get. I'm going to enter into the calculator 40.6 times 1 times 6.02 times 10 to the 23rd. I just read everything across the numerator. Then I'm going to divide by 56 on the bottom. And the answer that I get is 4.36. If you take a look at the end of your calculator answer, there is an exponent there, times 10 to the 23rd molecules. And we would expect a large answer here because molecules are very small, so there needs to be a big number of them. Alright guys, one more. How many grams of chromium chloride are in 7.14 moles of chromium chloride? Well, I know I'm being asked about grams, so I'm going to have to get the molar mass of that chromium compound, and I have moles to begin with. So this is going to be a conversion that's just one step, very simple, using this new molar mass concept. Let's go ahead and write our given down. 7.14 moles. And then I'm going to set that up. I need 1 mole on the bottom. And I'm going to have to find the molar mass of chromium chloride to put grams here on top. Now, up here, just in a little separate area, I count my atoms. I've got 1 chromium and I've got 2 chlorines. Now, to get the molar mass for chromium 2 chloride, I need to look on the periodic table. My chromium has a mass of 52 grams, and my chlorines are 35 grams each. So I'm going to write that here. 1 chromium times 52 is 52 grams, and 35 times 2 is 70 grams. So if we add that together, I get 122 grams per mole as the molar mass for that compound, and I'm going to plug that in right here. So when you do the math in your calculator, we are going to multiply. Let me get my pen back to blue for you here. I'm going to multiply 7.14 times 122 grams. Now the moles are going to cancel out, so those go away. We're left with our answer in grams, which is perfect. And when you do a little bit of rounding, you get 871 grams as the number of grams of chromium chloride in 7.14 moles. So those are lots of practice problems. We're going to do plenty more together in class, but I want you to start to recognize the pattern, writing down your given and using that molar mass to help you as a conversion factor now. See you later.